calculate the mean and the standard deviation to describe quantitative data. But we can also use the mean and the standard deviation to further describe data by calculating intervals that will contain certain percentages of the data. We can use the empirical rule or Chebyshev's theorem to do that. All of the intervals that we calculate are the mean plus or minus some number of standard deviations. K stands for the number of standard deviations we're going to go out. We use the empirical rule, which is better or stronger than Chebyshev's. So we use the empirical rule when the data is approximately symmetrical in mound shape, and we use Chebyshev's when that's not true. Again, empirical rule is stronger than Chebyshev's theorem, so it's a better procedure to use if you can. Let's look at an example. So I've got data that has a mean of 100 and a standard deviation of 12, and it's symmetrical and mound-shaped. So then by applying the empirical rule, I know that the mean plus or minus one standard deviation will contain approximately 68.26% of the data. Mean plus or minus two standard deviations will contain approximately 95.44% of the data. Finally, the mean plus or minus three standard deviations will contain almost all of the data, approximately 99.73% of the data. On the other hand, with the same data, if it's not symmetrical or not mound-shaped or both, then we can use Chebyshev's theorem. Here, the mean plus or minus two standard deviations, same interval from the previous page, now doesn't contain approximately 95.44%, but what we can guarantee is that it will contain at least 75% of the data. 1 minus 1 over 2 squared, and the 2 squared here, the 2 is the number of standard deviations that you went out. We can also calculate the mean plus or minus 3 standard deviations, and that will contain at least 88.89% of the data.